Okay. Number 16 says, consider the graph of the polynomial function f of x if the function g of x equals k times f of x maps the y-intercept of 0, -3 to 0, -9. What is the value of k? So, you should already have a point at 0, -3, right? Okay. All right, so we are mapping from 0, -3 to 0, -9. So where's our other point going to go?
-9.
On what axis?
Y.
axis. So go ahead and put you a point, -9. All right, now it says, what is the value of k? So look at where it says g of x equals k of x and then f of x. What operation is k doing with f of x? Multiplying. So I want you to draw a little bracket under that, and I want you to write multiply. So now we're thinking, okay, if I started at -3 and I got -9, yes, that goes down, but we're not adding or subtracting. We're doing what operation? Multiplying. So -3 times what is -9? 3. So my answer is D. So then over to under the points, I want you to write -3 times 3 equals -9. 3 is our k value. All right, number 17 says, a virologist is studying the spread of the flu. If there are 27 cases, underline 27 cases, of the flu reported in the first day, underline first day, and the number of people with the flu triples, underline triples, every day. Which function models the number of people who get the flu, underline the word after X days? All right, so what is the first term here? 27. So look at your choices. Do they all include 27? Yes. All right, then notice 2 of them say +3 and 2 of them say times 3. Well, we underline triples. If we are tripling something, are we adding 3 or are we multiplying 3? We're multiplying 3, right? So what 2 things can I mark out? A and B. Perfect. All right, so we got 27 cases on the first day. They triple every day, and we're looking for the number of people who get the flu after X days. If it says after X days, C or D?
I know C.
C, because it says after. So in order to know something, what happened after, you have to know what happened before, right? Remember that recursive n minus 1? In this case, it's x minus 1, okay? All right. Flip over to number 18. The population of a certain colony of ants doubles every 3 weeks. Underline doubles every 3 weeks. If the initial population of the ant colony is 315, under 315, which equation can be used to find the amount of time W in weeks it takes for the population to reach 1,000 ants? So, what are we trying to solve for? The amount of time, which is what variable? W. Okay. So, what is the first term here? 315. That's how much is our initial population. Look at all your choices. Do they all have 315 first? Yes. Okay. Then it says it doubles every 3 weeks. If something is doubling, Are we multiplying by 2 or are we multiplying by 3?
2.
2. So which 2 can we get rid of?
C and D.
C and D, because it says they're multiplying by 3. All right, and then it says every 3 weeks. So let's look at, I'm going to rewrite these. So we have 3, 15 times 2, W divided by 3 equals 1,000. And 315 times 2, 3W equals 1,000. All right, and that first one, and the A. Once we get ready to solve for W at the end, okay, we're going to have a W over 3. I've got to get rid of that denominator to get W by itself, right? How would I do that? Would I divide by 3 here or would I multiply by 3 here? I multiply by 3. So look, it's the same concept as if I said 1, let me change colors. If I said 1 over 2x equals 10, what would you do to both sides right there? Multiply by 2. And then what happens to the 2's on the left? They cancel. So you're just left with 1x equals 20. Alright, so same thing here. Once we get ready to solve for W, we're going to multiply both sides of the equal sign by what? 3. It says W over 3. Alright, now look at the one on the right. At the end, we get done, we get rid of all that stuff. We've got a 3W equals something. What are you going to do? Divide by 3, right? On both sides, whatever you're doing. So, if it's doubling, okay, is it getting bigger or is it getting smaller? It's getting bigger. So, out of these two options, is multiplying getting bigger or is dividing getting bigger? Multiplying, right? So which one are we multiplying by? Are we multiplying by A or are we multiplying by B? Multiplying by A, yep. Take your Y equals in your calculator. And I want you to type in 315 times 2 and then raise it to the power of x over 3. Use an x instead of a w just because it's easier. Okay, so I'm going to do the same. There. All right, it should look like this. Once it looks like that, I want you to hit second graph and bring up a table. And I want you to make it highlighted where x equals 0 like I have on mine. So, at week 0, how many ants do I have? 315. That's what it says right next to it, right? Then it says it doubles every 3 weeks. So from week 0, what week are we on in 3 weeks? 3, right? No trick question there. Week 3. On your calculator, what does it say the ant population is when it's week 3? 630. See the 3? Right next to it, it says 630. If something is being doubled, it's being multiplied by what? 2. What is 315 times 2?
630.
630. So we are certain this is our answer from this table. Okay? On number 19, I want you to read that top paragraph of 19 by yourself. How much of that really matters? Do you think any of it really matters? Looking at your answer choices, do you think any of it matters? More than likely, when you've got a graph and you've got 2 lines and they're crossing, they are looking for the what of those 2 lines? Not 0. The intersection, right? So let's look at the choices. It says, choice A, the point 0 to 100 represents both. B says 575 represents both. C says 80 represents both. D says 75.7 equals or represents both. What is the key word in all those choices? Both. So, for it to be both lines, it's got to be the what of those lines? The intersection. So is 0 to 100? If we put a point at 0 to 100, well, that looks like it's on one line. What about 575? What is that? That's the intersection. So that hits both. What about 80? That only hits 1, right? And what about 75.5? Is 75.5 even on there? No. So the answer has to be B. Why do you think they put D on there? So you get them mixed up. But the coordinate points are written as X, comma, Y. So you go which way first? What or what? Or? So you go right, left, and then Y is up or down. Okay. Number 20. For every X minutes of cable television programming, 14 minutes are dedicated to commercials. Underline 14 minutes. For every X minutes on a particular online streaming service, 4 minutes are dedicated to commercials. Underline 4 minutes. A new streaming service wants to compete by offering the average, underline the word average, commercial time between 2 other options. What is the ratio that represents the average number of minutes of commercials to X minutes? So I want you to underline this part, this big part. Average number of minutes of commercials to X minutes. Now looking at your answer choices, what do you think that 2 means? Not the number 2, that TO. That's going to be where the what is. The colon, right? So just go ahead and put your colon right there. And then we're looking for the average on the left. And then what's going to be on the right? X minutes. So let's just put an X. How do you find the average? What is the average? The average, you add all your terms up and then divide by the number of terms. Well, what are the only 2 terms that we're given here? 14 and 4. So we've got 14 plus 4, which is 18. And then we divide by the number of terms we have. So we divide 18 by 2. 18 divided by 2 equals 9. So what's going to be on the left of our colon? 9, right? Because that's the average. And then on the right, it's just going to be that x. So my answer has to be B. All right, number 21. Number 21 says the value of a computer decreases by 35% each year if the computer was initially sold for $1,250, which function represents the value V of t of the computer t years after being sold. What is the most important word in that problem?
Decrease.
Decreases. You need to underline that, circle it, highlight it, something. If you do not see that word decrease, you will pick the wrong answer. Okay? If something is decreasing, it's going what?
Yeah.
It's going down. Okay, so let's think about this. We got a whole percent. We are doing really, really good right now. Whole percent. So that's what percent? 100%. And I am decreasing, so I'm adding or subtracting. Subtracting by 35%. What's 100 minus 35? 65. 65%. Okay. Looking at your choices. There are 2 for sure that I can knock out. Which 2? B and D, because they say 35. So if you would have missed decrease, you would have put what? You would have put B or D because you just saw the 35, right? But we didn't miss it. We saw it. Now, you have to remember that you cannot put a what in an equation. A whole percent. You got to change that 65% to a decimal. So when we change that, it becomes 0.65. So the only possible answer here is C. Out beside part A, I want you to write percent. Remember, you cannot put a percent in there. Okay? All right, we are dealing with y-intercepts here. Y-intercept is when the x equals what? 0. Good. So in function 1, what is the y-intercept? Negative 12. So I want you to put a box around that. All right, in function 2, what is the y-intercept? Not negative 2. How many times do I need to write x minus 2 there? I need to write it 3 times. Now, in order to find the y-intercept, do I really need to multiply all 3 of those polynomials? What do you know about y-intercepts? They're just a what? They have a letter attached? No, they're just a what? They're just a number. So, can I not say negative 2 times negative 2 times negative 2 if we know it's just a number? Now, if it was asking for the x squared term, we would have to what? We'd have to multiply it out. We'd have to use the box. But right here, we're just asking for the y-intercept. Right? What is the y-intercept? Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. Now we're looking at the distance between those two things. So what is the difference between negative 12 and negative 8? 4. Good. Now, another thing. Let's say we didn't know what to multiply by. Can I go to my y equals and type in x minus 2 cube, like so? And then I can go to my table and I can look for when x equals 0. Well, when x equals 0, there's my y-intercept. Okay, so either way. All right. 23 and 24. So we have not learned 23 and 24. Not the least bit. So we're fixing to learn it. Okay? So, at the top of your page, up here above the calculator, I want you to draw me a sketch of this. That looks bad. Oh, that still looks bad, but oh well. Alright, this is a bell curve. Okay? This is done in probability, statistics. Okay? I want you to draw a line straight down the middle of that bell. Why do you think it's called a bell curve? Curves like a bell. Yep. Alright, so straight line down the middle, and I want you to write the word mean above that straight line. And then I want you to draw a line to the right of it, to the left of it, to the right of it, to the left of it, right, and left. All right, then I want you to write plus 1 SD plus 2 SD plus 3 SD. And then to the left, the same thing except minus 1 SD minus 2 SD minus 3 SD. All right, then I want you to write these purple numbers that I'm fixing to write are the same every single time, okay? 34.1%, 34.1%, 13.6%, 13.6%. 2.1%, 2.1%, 0.1%, 0.1%.
It's kind of like the thing that we learned yesterday. How it's the same on both sides.
The same concept of being both sides, but two completely different topics.
Yeah.
I don't have a cool trick for it though. All right. So we're going to use this bell curve to answer 23 and 24. But before we start, I want you to add up all 8 of those purple numbers. All your purple numbers add up to be 99.8. Sometimes a bell curve will add up to 99.7. So they range 99.7 to 99.8. So they got a 10th off somewhere. So the problem says the ages of the people in the population are normally distributed with a mean of 35. Underline mean of 35. And a standard deviation of 6 years. Underline standard deviation of 6 years. What do you think SD means on this bell curve? Standard deviation. Okay. So what is the mean? 35. So we are writing 35 underneath the word mean. All right, then it says a standard deviation of 6. Okay, so standard deviation. I'm going to add that standard deviation to 35. So plus 1 standard deviation is going to be 35 plus 6. What is 35 plus 6? 41. All right, plus 2 standard deviations is going to be 41 plus 6, which is what? 41 plus 6? 47, yes. I thought you said 57. I was like, ooh. 47. All right, plus 3 is going to be what? 53. So what am I doing every time? Adding 6 more.
If you go to the left side, you subtract.
On the left side, you do subtract. So I've got 35 minus 6, which is 29. And then I say 29 minus 6, which is 23. And 23 minus 6, which is 17. So the red part is what's going to change every time. Okay? All right. Part A. Which statement is true? Approximately blank percent of people in the population are between 29 and 41. So 29 and 41. Well, here's where 29 starts. And here's where it ends, because look, here's 29 and here's 41. What is the percentage in that green bracket? 68.2, which is pretty close to what percent? 68%. So all I did was say 34.1 plus 34.1. That's my percentage from when it's 29 to 41. So A would be, part A, 23 would be C. All right, so what I want you to do now on part B is I want you to draw your own bell curve. But part B goes with that second bullet point. It says the height of the people in the population are normally distributed with a mean of 67.3. So, let me erase all my red. Go ahead and draw you a bell curve. With your percentages. What number is going at the top of the mean? Question says approximately what percent of people have a height. So we're looking at the problem that asks for the height. So if you go back to where you're supposed to read, it says the height of the people in the population are normally distributed with a mean of 67.3. So what's going at the top? 67.3. So write 67.3 for the mean. Then it says the standard deviation of 3.6. So what are you going to do every time on the right side? Add 3.6. And on the left side, you're going to subtract 3.6. So do that. All right, what is the height when it's plus 1 standard deviation?
70.6.
70.6. All right, Callie, what's the standard deviation when it says, or what's the red number when it says plus 2 standard deviation? So 70.6 plus 3.6. So 74.2. Jacob, what's plus 3 standard deviation? Mm-mm.
That's what I got.
Wait, what'd you say?
74.2 plus 3.6. 77.8.
77.8. Okay. Wait, we messed up somewhere. All right, so that should be 70.9 plus 3.6 should be 74.5 plus 3.6, 78.1. Now, if you subtract all that, start back at 67.3 minus 3.6, what do you get?
62.7.
Yep. Subtract 3.6 again and you get,
60.1.
yep. And subtract it again and you get 56.5. Okay. All right, so the question says, approximately what percent of the people in the population have a height between 56.5 and 78.1? Well, what do you notice? That's the entire what?
Bells.
That's the entire curve, the entire bell. Because look, we're all the way over here at 56.5. Go all the way over to 78.1. So which of those numbers is it going to be?
D.
D, 99.7, because that's the closest one to 100%, right? Says, which expression is equivalent? What does the word equivalent mean? Equal, so I put equal above that. So we are trying to see which one this is equal to. Now, can we type in that entire function that I've written in red? No, because there's a what in there? There's an X, there's a letter, right? But remember the store function I showed you? STO? Yes? On your calculator? Let's try that. So go to your calculator. Type in 8. So 8 STO above the on sign, X, enter. Now we can type in that function, okay? Because 8's stored. So 8 parentheses 25 close parentheses, raise it to the power of 4x, hit enter.
4.3.
You should get this long number with the e to the 45 at the end. Does everybody say that? Okay. Now, when we get ready to type these equations in, we are looking for the one that does what with this one. If something that is equivalent, they've got to be what? Equal. So let's just start with the first one. 8 parentheses 5 close parentheses and raise it to the power of 8x. Does it match? So what's my answer here? A. Now let me show you something else. Type in your calculator. 25 to the 4th power. What do you get?
39,625.
Wait, say that again.
39,625.
39,000 or 390,000? 625? All right. So where did I get 25 to the 4th from? The parentheses in the exponent. 25 times 4, right? All right, so now do 5 to the 8th power. So since those equal, what's your answer? Still A. Right. Yep. You can do that either way. All right. We're going to skip 26 and come back to it at the end. Okay, because I want it to be the last one we do. All right, 27. Easy way, hard way. Easy way. Always. All right. So, we've already got the square by itself. You agree? On one side? How do you get rid of a square? Take the square root. So we square root both sides. And we're left with this. X minus 13 squared equals the square root of negative 64. Well, I can't take the square root of a what kind of number? A negative. But I can take the square root of the positive number and put that cute little what out beside it? Cute little I, right? So what, on the left side, what happens to the square and the square root? A cancels, so we're just left with what? X minus 13 equals. When we are solving square roots, we have to have both the what and the what number. Positive and negative. What's the square root of positive 64? 8. So the square root of negative 64 is plus or minus 8i. Sure is. Now we got a one-step equation. What do I do to get x by itself? Plus 13. So x equals, where does that I go, in the front or the back? Back, so this one is 13 plus or minus 8i, which is D. Now, if we got to, let's say, right here, and we didn't know what to do. We didn't know we needed to move 13. You know that your 8's got to have a what on it? It's got to have an I. So there are two choices that I can mark out that don't have an I on the 8. What are those two? B and C. Then you got a 50-50 shot. Okay? All right. 28. All right. It says, what is the remainder? Okay? When it's asking for the remainder, you're probably going to do either what or what? Long or synthetic. Okay. Let's use a little common sense here. Okay? Synthetic, you have to use the what? Solution, right? Okay. So let's just, I don't know, try to solve this maybe for x, for the solution. Add 3, subtract 3. Subtract 3, and we've got x squared equals negative 3. How do you get rid of a square? Can I do that? No, so I cannot use what kind of division here? Can't use synthetic. Have to go long. Okay? So, this should be fun. X squared plus 3. Under my box is x cubed plus 12x squared plus 7x plus 1. How do I start? What divided by what? X cubed divided by x squared. If you do it this way, you gotta know your exponent rules. When you're dividing, what do you do with your exponents? Subtract. So 3 minus 2 is just x. So we have an x up here. Alright, after we divide, then we multiply. So we have x times x squared plus 3. Well, x times x squared is x cubed. And x times 3 is 3x. But it's missing which term right there? So we went from x cubed to a 3x. Remember, when you subtract, you got to line up your stuff. So I'm missing x squared. So what do I need to put in that placeholder just to help me? A 0. All right, then we subtract. Don't forget your parentheses. X cubed minus x cubed, they just cancel. 12 minus 0 is still 12. 7x minus 3x is a positive 4x. And then we bring down the 1. And then we start over. So, 12x squared divided by x squared just leaves me with just 12. So we have plus 12 at the top. Then we multiply. 12 times x squared plus 3. Well, 12 times x squared, 12x squared. 12 times 3 is a 36. But here again, I'm missing what term? The x term. So let's put a 0. What happens to those 12x squareds? Cancel. 4 minus 0 is 1 minus 36 is, well, I have nothing else to bring down. So my remainder is
-0.
4x minus 35. When you have nothing else to bring down and you're left with whatever's down here, that's your remainder. So is that a common remainder we've seen? No, we normally have just a number. Okay? So you would write this like any other remainder. All right. 29. So we are looking for somebody else's mistake. Okay? So we're given the equation, and then it goes to step 1 all the way to step 6. Okay? So, in order to do these rational expressions, you have to have a common what? If you're adding fractions, you got to have a common denominator. Okay, so I have a common denominator on the first one and the third one, but I don't have a common denominator on my what? On my 6. So that's why we multiplied by x minus 3 on both sides. So I'm fixing to write out what that would look like, okay? So I want you to write it out too. There's the first one. There's the second one. There's the third one. So that's what step 1 looks like. What can I do after step 1? If you were solving this problem, what would you do next? You would cross out, right? So we're going to cross out what in the first section? X minus 3. What are we going to cross out in the second section? Anything?
6 minus 3 again.
I don't have anything on the bottom, though. Oh, that's over 1. What about the last one? X minus 3. So let's double check with step 2 that they match what we have. Do we have an x plus 1? Yep. Do we have a negative 6? And x minus 3 equals 3. Do we have the same stuff? Okay. All right, let's look from step 2 to step 3. To simplify from step 2 to step 3, what would we need to do with that negative 6? Distribute. So negative 6 times x is what? Negative 6x. That's what that says. But negative 6 times negative 3 is a positive 18, but it says a negative 3. So the error occurs between step 2 and step 3. All right, number 30's got to be the easiest one on here. A new ice cream shop is trying to determine its hours of operation. The shop opens for one day to determine the most popular times for business and records the number of ice creams sold each hour. So we're looking between each hour of how many they sold. From the first hour to the second hour.
27.
How many ice cream cones did he sell?
27.
Between hour 1 and hour 2.
80. 34.
34. 61 minus 27. All right, so he added 34 there. But then from hour 2 to hour 3, he went where? He went down. What about from 3 to 4? He also went down. What about from 4 to 5? He added. And then from 5 to 6, he added. Which one of those is the most popular time? 1 and 2, because he sold 34 ice cream cones. Easy enough? All right, 31. A family travels 620 miles, underline 620, to visit grandparents over the holidays. If the family travels 70 miles the first hour, underline 70 miles the first hour, and 55 miles each hour after the first. Okay? We're writing an equation. So we started out with how many miles? 620. That's how long it took us to get to our grandma's. But in the first hour, our first term, we drove 70 miles.
So 550 miles.
So if the total thing was 620, but I'm looking for that first term, 620 plus 70 or 620 minus? Minus. which is 550. So we know now our new first term is what? 550. So we're going to mark out which two problems? A and B. All right. Then we drove 55 miles each hour after the first. When it says after, we have to have a what? An H minus 1, because we have to know what it happens after. But in order to know what happened after, we have to know what happened before. So the only correct answer here could be C. The big key word there is after. All right, 32, easy, hard. Easy. So easy way would be exponent rules. Hard way would be longer synthetic division. Okay? When you're dividing, what do you do to your exponents? Subtract. So I've got an x squared on the top and an x on the bottom. So 2 minus 1 is just 1x. So 3x squared divided by x is just 3x. Then we have a negative 27 divided by a negative 3 is a positive 9. So my answer is D. Now we could also do synthetic long division. Do y'all want me to do it that way? Okay, cool. I don't want to do it that way because this is the easy way. We don't want to make things harder. Okay? All right, 33. Which statement is true? All right, so from the given step to step 1, what did this student do?
Swap the 5.
They added 5, right? They swapped it. So we have x to the 4th equals 81. Just like a square root, just like a cube root, just like any root. In order to get rid of that, we take what kind of root of 81?
4.
Now, when you go to your calculator and you hit math, is there one that has a 4 on it?
You do 5.
There's not one that says 4, but we can go down to 5. Change it to 4. All right. So you hit math. 5. Where it says A and S, change that to 4. 81. And you're going to get 3. But what kind of number is 4? An even number, right?
4 is negative.
Would a negative work? Yes. Because 3 times 3 times 3 times 3 is 81. You agree? But also, negative 3 times negative 3 times negative 3 times negative 3. These two negatives right here make a positive, and these two negatives make a positive. So my answer is positive 81. So my answer here would be A. Now, does that work on odd numbers? If your power is odd or your root is odd, it's going to be the positive one only. If it's an even root and even power, it's going to be positive and negative because two negatives make a positive. Okay? All right, one more. Let's go back to 26. All right, what are the solutions to the equation? All right. So, look at your answer choices, first of all. they all have a cute little what? They have a cute little eye. So you know your solutions are going to be imaginary. They're going to be complex. So if you were to graph this, would you see them? No. Okay. Since they are imaginary complex, can you use the big X? No. We got to use the quadratic formula. Okay. So, right here, can I solve it the way it looks? No, because everything is not on one side. So we have to move it. Okay. So let's move 6x and negative 10 to where we get 3x squared minus 6x plus 10 equals 0. Then we plug in. What is the formula? Negative b plus or minus square root.
Of b squared.
Yep.
Minus 4ac.
Yep. Yep. Perfect. So we have negative 6 plus or minus the square root of negative 6 squared minus 4 times 3 times 10 all over 2 times 3. All right, so we're going to be able to simplify, but it's going to be a wacky simplifying process, okay? So, 2 negatives out front make a positive 6. So we have 6 plus or minus the square root. Type in your calculator what is under the square root using parentheses and everything.
Negative 84.
Okay. You should get negative 84. Everybody get negative 84? Okay. Let's leave 2 over 3 for right now. And you'll see why in a minute. Alright, so 6 plus or minus over 2 times 3. Alright, can I simplify that square root? It'll have an I. Yes, it will have an I. But when you simplify it, is it going to be perfect? No. But it is an even number, so we can probably do the factor tree on it. Okay? So let's do a factor tree. 2 biggest numbers, 84, are 12 and... Not 4. Not 6. 7. All right, what do you know about 7? It's a what kind of number? Prime number, so it can't be broken down. What about 12? 6 and 2 or 3 and 4? 3 can, yes or no? No, 4? 2 and 2. All right, what do we do right here? We circle our pairs and box what's left over. So what are the 2 numbers that do not have anything attached to them? 3 and 7. Where did I get 2 square root of 21? I just brought my pair up, which is just 2. And then 3 times 7, which is 21. Yep. And why'd I put an I right there? Because it's a what kind of number under that square root? A negative, right? Okay. Now, what is another way that I can write the number 6? What times what? Besides 1 and 6? 2 times 3. So watch what I'm fixing to do. So I'm fixing to erase this first. Two times 3 plus I2 square root of 21 over 2 times 3. Have I changed the value of anything? No, I just renamed 6 to be what? 2 and 3. Now, in the numerator, okay, on the top, is there a number that I can factor out? Just in the numerator. I can factor out a 2. So watch what I'm fixing to do. If you multiply this out, 2 times 3, you get, here's your 2 times 3. If I say 2 times I to the square root of 21, 2 times I to the square root of 21. Okay, so all I did was factor out a 2. Now, the reason I did this is because I'm trying to cancel out something. Is there a number on the top and the bottom that's alone that I can cross out? I can cross out this 2. And I can cross out this 2 because I got 1 on the top and 1 on the bottom. Can't cross out the 3's because that top 3's got a what attached? It's got the I and the square root. So looking at your answer choices, which one matches what we have left? B.